I'm going to do problems from the last part of 8.4 that you were assigned. You were assigned problems 35 through 43, all odds and evens on page 487. And I'm going to do, let's see here, I'll do problem 38. I will do problem 40, problem number 41 and 43. So 38, 40, 41, and 43. So you're assigned 9 problems. I'm going to do 4 of those. So I'll start with 38. And 38 has 2 root 6 minus 5 root 54. So look at this problem. Right here we have 2 root 6. There's not much you can do there because 6 is composed of 2 times 3 and none of those are perfect squares. So that's going to stay as is. Looking at the second number, 5 root 54, 54 has factors that are perfect squares. So we are going to break it down in a way so we can get some perfect squares. Now you can break down 54 into 2 times 27. Neither 2 or 27 are perfect squares, so that doesn't help us. Let's see what else you can break it down into. What about 6 times 9? That works, and while 6 is the perfect square, 9 is, and that's what we're looking for, so that's going to be the preferable way of breaking this problem down. So I can write this as, I'm going to leave the first one untouched, but the second number I can write it as 5 times root 6 times root 9. So I just broke up the 54. The product property allows me to break them down into 2 different factors. And once I did that, again I'm going to leave this as is, but over here I can write the 9 as 3 squared. As I told you before, I can cancel out any powers of 2 with the square root. And once I do this, I end up with 2 root 6 minus 5 times the now liberated 3 is negative, or just 15 because it's a minus, root 6. Now they have common terms, like terms, so to speak. They both share a root 6. If that's the case, you work on this problem just like you would if you had a problem with 2 of the identical variables. You combined your like terms. 2 minus 15 is negative 13 root 6. And that is the answer for 38. So you broke up the second number, the 54 under the root, into factors that yielded a perfect square. You took that perfect square out of the root. Once you accomplish that, you now have 2 numbers that have the same number underneath the root. You treat them like terms. You combine them. In this case, you still combine them, but that's a subtraction. So, or a difference, and that's your final answer. Next up, I want to tackle number 40. So number 40, you have 3 root 7 minus 5 root 14 plus 2 root 28. So look at it right now. None of these problems have a common root, so to speak. None of them are like terms right now. Looking at the first number, we have 3 root 7. 7 underneath the root is a prime number, so that's not going to go anywhere. And that gives you a hint as to what the other numbers should look like so that you can combine them. So after we do some work with these two, we're going to get a perfect square out of there, hopefully. And then we might be able to make them all into like terms? We'll see. Let's work on them individually and see what we get. So the 5 root 14, 14 is a factors of 2 times 7. Well, neither the 2 nor the 7 are perfect squares, so we won't be able to get anything out of there. But let's write them down separately and see what we get. So I can write this down as 5 root 7 times root 2. Looking at this for a bit more, I don't think there's anything we can do here. So I think that 5 to the root 14, it's just going to stay there. Yeah, there's nothing we can do there. So we're going to ignore that middle term for right now. We're going to leave it as is. So forget we did this work here. Again, that 14, yeah, we can break it down into 2 times 7, but neither of those are perfect squares. So it doesn't really help us get anywhere. So yeah, that one is stuck. Let's look at the last one. The last term is 2 root 28. 28 can be broken down to 4 times 7. And 4 is a perfect square. So you can break it down into this, which then gives us this. And then, as I said before, you can cancel out powers of 2 and their square root, and you end up with 2 times 2 root 7, which gives us 4 root 7. Now writing them back in sequence, I get 3 root 7 minus 5 root 14. Again, I'm going to just keep it as a root 14 because even if I break it down into root 7 times 2, I won't be able to do anything there. Plus now this, which is 4 root 7. So now I see if I have any like terms or anything with the same root that I can combine. This and this I can, but there's nothing I can do to the root 14, so that's just the odd man out, I guess. 3 plus 4, that's going to be 7 root 7, and then the odd man out, the 5 root 14. That's our answer. Yep. So that's number 40. Let's do number 41 next. We have root 5 multiplied by 5 minus root 5. So we didn't run into this scenario in class where you had to distribute a root, but again, you treat it just like a variable or anything else. So if you had something in front of the parenthesis, you would just distribute it evenly to all the members of the parenthesis. So that's going to yield root 5 times 5 minus root 5 times root 5. On the left here, well, nothing we can do there. That's just 5 root 5. I rewrite it with the number outside of the root goes first and the root goes second. Minus, well, that's going to be 5 squared. 5 times 5. And we can cancel out its root, which gives us 5 root 5 minus 5. And there's nothing else we can do. That's it. That's the answer. We can't combine a problem that's root 5 and a number that has a root 5 and a number that has no root at all. So yeah, they're not like terms. So that's about it. And the last problem I want to do is 43. For 43, we have root 3 being multiplied by 6 root 2 inside the parenthesis minus 4 root 3. Just like before you do anything else, you have to distribute whatever is outside of the parenthesis to every single member inside. So So that's going to yield 6 root 2 times root 3, this times this, minus 4 root 3 times root 3, this times this. This is going to be 6 on the outside and then 2 times 3 on the inside. 6 root 6. Minus, over here, it's going to be 4 on the outside. And inside it's going to be 3 times 3, which is 3 squared. Okay. Well, squares cancel out their roots. That gives us 6 root 6 minus 4. Well, that was kind of uneventful, because that's it. That's all we can do. Not too bad at all. That's it for this homework. You have 5 other problems to do, but the rest of them are rather easy, so you should be able to knock those off real fast. If you have any help, just ask me during class or see me before school, at lunch, or after school on Monday. Have a nice weekend.